So this is multiple choice question number 3 from the AP Stats test preview available through Bluebook. And this multiple choice question says, then 2011, we've got a survey of 200 adults and 17% of them said they consumed at least 3 pounds of bacon during that year. A few years later, they had the same survey, bigger sample size, 600 is the sample size this time, and we have a higher percentage of adults saying that they consumed at least 3 pounds of bacon that year. Tells us to assume that all conditions for inference are met and try to decide which of these answer options is the most appropriate test statistic to investigate whether there's a different proportion of US adults that consumed at least 3 pounds of bacon in 2016 versus 2011. So hopefully you realize that it's appropriate to try to assign a null and alternative hypothesis here. The null hypothesis is always going to be an equality. We're going to assume that there's no difference between the two proportions from those two separate years. The alternative would be that there is a difference. Now, phrasing in the question is going to indicate whether you use not equal to, greater than, or less than. Phrasing here flat out says is different, so not equal. Now, usually whenever you're setting up a significance test to compare proportions, it's helpful to think about equivalent forms of the null and alternative hypotheses. If you simply subtract the proportion from 2016 from both sides of the null and alternative hypothesis, what you end up with is you end up with a difference in the proportion from 2011 and the proportion from 2016 on the left, and just a 0 on the other side of each hypothesis. Now, to compute a test statistic, which in this case, for comparing proportions with a sampling distribution for proportions, we're going to be using a z statistic. We're going to take the statistic, so the value that we measure from our sample minus the parameter. The parameter in a significance test is always what's true about the null hypothesis, and then we're going to divide by the standard error. So my numerator is going to be the proportion from 2011 minus the proportion from 2016 minus 0. So I'm going to take proportion from 2011 minus the proportion from 2016 minus 0, right? The alternative hypothesis, or excuse me, the null hypothesis value difference is 0. That's what every numerator says. So obviously we're going to have to reason out which denominator is the appropriate one for us to go with. Now, if you look at the formula sheet in the section that involves a sampling distribution for a difference of two proportions, when you assume that the two proportions are equal to each other, which is exactly what we're doing with this null hypothesis here, anytime you run a significance test, you're assuming the null hypothesis is true until potentially the very end of the process. If we assume that the two proportions are the same, the standard error that we're going to compute is going to be computed with this calculation here, where P sub C is the combined proportion or the pooled proportion. So the formula for the pooled proportion is to take the raw count that responded yes from the 2011 sample plus the raw count that's responded yes from the 2016 sample and divide by the sum of the two sample sizes. So you do have to do a little bit of work to realize that 17% of 200 is 34 and 25% of 600 is 150, but that's pretty straightforward to do. So my pooled proportion value ends up being 0.23. So I'm putting 0.23 here, I'm putting the complement of 0.23 here, and then I'm multiplying by the sum of 1 over the first sample size plus 1 over the second sample size. And if you look at our answer options, the only one that resembles what we built is option D.